Hello, and thank you very much for joining me for one of the very last talks in the conference. I think we are all tired at this point, but hopefully it should be a good talk. If you have been an Android developer, then you have used main thread definitely, but heard about message queue, handler, and looper and what they do. Today I will talk about all of these stuff. I am Hadi Tok, and I am a software engineer at WhatsApp, and I am an Android GDE. Let's start with main thread. What is main thread? It's basically the threads dealing with the user interaction and drawing the user interface on the screen. If you are dealing with the widgets or view packages, then you definitely need to deal with the main thread. But why there is only single threads handling all these things? The biggest reason is the synchronization of the UI resources could be really hard. Because if you think about it, we have a lot of views, user interactions, and these are all resources. So having one single thread creates a boundary between all these resources, so we don't have to worry about the thread safety, also synchronization and these kinds of things. And the downside of having a single thread is a lot of things trying to use main thread to do different things. As I mentioned, drawing a UI, collecting the user input, also other unnecessary stuff we developers wanted to do. Ben gave a talk yesterday about modern Android performance and thought that you should stay off the main threads, and it's really important. Otherwise, if you are doing a lot of unnecessary things in the main threads, user experience may suffer. Main threads can run multiple runnables, one at a time. These runnables should be provided somehow to the main thread to be executed. This is done via message and message queue. Let's look at the message first. Message is a wrapper on the things that needs to run on the main threads. It can contain two things. The first one is a runnable called callback. The second thing is a message code. The callback, if you have them post on a view or a handler, then you are providing that runnable to the message. And message ID is usually used by the system. These are a bunch of integers. They are checked in a switch, and Android decides what to execute without having to create runnables for these common operations. But we don't need to be worried about these too much. We will mostly focus on the runnable side of things. Let's look at the message queue. It's basically a queue that is holding the messages that needs to be dispatched by a looper. If we visualize it, it's basically something like this. So we have some runnables and messages in the message queue. It has a back and front, as you expect from a queue. But what's a looper? A looper is a class to run message loop for a thread. If you look at this definition, it doesn't make sense. But if you look at the code, it makes more sense. It has basically a for loop that's running infinitely and fetching messages from the queue and dispatching these messages. So our looper sits in here and fetches messages from the queue and within the runs the infinite loop to execute them. If we look at the dispatch message function, there's an if-else. So basically, if there's a callback, it will execute the callback. Otherwise, it will need to use the message code to be able to determine what to do. Handle callback method is really simple. It just runs the runnable. We already looked at this part of the definition, but the second part of the definition is we don't directly interact with the message queue, but we need to use a handler object. What's a handler object? It allows us to add messages to the queue, basically. I thought it is also could handle the synchronization, but it doesn't really does that. Message queue does the synchronization on its own. So we can basically use the handler in a couple ways. The first one is enqueuing an action to the queue that will be performed within the thread. Let's say we have a handler and it wants to place a message within the queue. There is not many options we have here. The first option is adding the message at the back of the queue. To do this, we have this post function. You've probably used it in one of these forms. The first one is you can use view.post. It is usually used to delay things a little bit, so the message queue, the thing you want to execute should be executed at the last of the queue. The other usages, if you are on a background thread and if you want to go back to the main threads, you can do post on a handler and it will add your messages to at the end of the queue. And finally, if you are using live data, you have the post value option. If you are on background, it will come to the main threads. And handler also can place messages in the beginning of the queue using this post at front of queue function. But we really don't want to do that, because if we keep adding stuff in the beginning of the queue, other things at the back of the queue will not have chance to be executed, and it will have unforeseen consequences. So we shouldn't use it at all. Handler also can schedule messages. You can determine when they will be added at the back of the queue. For these, we have post delayed. You can provide a delay, and after this delay is passed, it will be added at the back of the queue. We also have post at time, and you provide a specific time. When that specific time comes, your message or your runnable will be added at the back of the queue. But this is not system current milliseconds, millis. It's based on system clock uptime millis. This is when your app is started, and this time starts when the app is opened. I tried to use system current milliseconds to post at some time, but it didn't work. That's the reason. So there are a lot of things competing to be executed on the main threads. In an ideal world, we have logic separated from the UI, and all the logic-related things are executed in a background thread. We also have observables like live data or flow, and they are lifecycle. We don't care about in which order we receive values for these observers. And finally, we have lifecycle aware constructs, and we don't need to worry about things trying to be executed when the activity is being destroyed. But in a non-ideal world, things try to execute it on the main thread, and that we will have some race conditions. To simulate that, I added some logs to the activity lifecycle, as you would expect. On create, on start, on resume. I got my logs in this order, and when I press back button, I have on pause, on stop, and on destroy. Nothing unexpected. As my second trial, I added a post block and added a log within the post, and I added this logging to all lifecycle callbacks. When I execute it, I have on create, on start, and on resume logged consecutively. This tells me that these are all executed in the same runnable. But we know that on create post, on start post, and on resume post, they have their own runnables, so they are executed after these callbacks. The finishing lifecycle callbacks, it's a little bit more interesting. We have pause and pause on post. They are logged consecutively, but on stop post and on destroy post are executed after on destroy. This tells us that if you are doing a post in on pause methods, then it should be safe to do. But when you are in on stop method, you shouldn't do that, because if you are doing, you should check if the activity is actually being destroyed, or you shouldn't access any UI-related resources at all. So there are cases that you would like to learn width and height of some views. And in onCreate methods, you can access almost any of the other properties of the view. So why not access width and height also? If you run this code, you will not be able to get the width height values, you will get zeros, even though my view is visible and has some text on it. The reason is, while activity is being created, the drawing does not happen now. It would be delayed for a later time. If you go out to Stack Overflow, and one of the answer is run this code in a post delayed with 100 milliseconds of delay. But this is like a magic number, how you can be sure that it would be completed in 100 milliseconds. So we shouldn't probably use that. Instead, there's another convenient method. It's called onGlobal Layout Listener. In my next experiment, I have all my logs, regular log in a post, and finally I put another log in the global layout listener. If you look at the logs, it is pretty similar to my initial experiment, but the global layout listener log is in the very end. So it tells me that I will not be able to measure any views within these activity lifecycle callbacks. In the next experiment, I have a view model. It contains the live data, and its type is a string. And I have two methods. The first one is post string on live data. It's doing a post live data on the live data, and the second one is doing a set on the same live data. From my activity, I have a call to observe this and log the string date it receives from the live data. And I'm triggering these two functions that I've just shown. The first one is set string on live data and post string on live data. And in the very end, we have the regular onCreate log. If I look at the results, I have onCreate, onStart logs in the beginning, but I have the set live data log between onStart and onResume. I think it's pretty interesting. Initially, I would expect it should happen after onCreate, but why it's between onStart and onResume? In the previous example, we showed that onCreate, onStart, and onResume, they execute consecutively in the same runnable. So how this thing is happening? I attach the debug points and find out about this method. The call is originated from this method. It's dispatch activity post started. So it runs after onStart is complete. That means we start to receive data from live data after onStart is passed. So we shouldn't depend on any data if we are using a live data within onStart or onCreate methods. In the same example, I have the post string on live data. It's just after onResume. It behaved exactly like posting from the onCreate methods. So we can say that posting to a live data has a similar behavior when we do it on the activity itself with the post methods. In my next experiment, I have moved these set and post methods to onResume because onCreate had this unexpected life cycle issue. So I want to see how set and post would be received on the activity side. You can see that after onCreate and onStart, I have onResume methods with the set live data, set string on live data log, and I have regular onResume log. If I go back to this, you can see that set string on live data is executed before the regular log. So we can say that if we are on main threads and if the activity is starting to receive callbacks from live data, then it executes like it's in the same runnable. It's not going to get posted or anything. On this experiment, I have two set string on live data. I'm passing onResume1 and onResume2 strings into these methods. Let's see what's going to happen. It behaves like the previous case. We have onResume1 and onResume2 logs are logged before the onResume log. Not many things are unexpected here. But I want to see what happens when I do post instead of set. If I look at the results, I don't see that first post string on live data log. That's because how live data works. So if you are on a background thread, and if you want to update the UI using live data too frequently, live data drops the values if a new value is received before the post gets executed. So this is not really usable. So if you want to update the UI too frequently from a background thread, it's not really way to go. So from what we saw, the main takeaways are we shouldn't use post at front of the queue function. It should be used really in unique cases. The second thing is we shouldn't use post delayed for doing view measurements. Instead, we should use global layout listener. We can observe from live data after on-start is executed. So we shouldn't depend any value before that point. If we are in the main thread, we can use set value, and it's going to be executed in the same runnable. And when we are also in the main threads, we should decide wisely when to use post value and set value. If we use set value, it's going to be executed like within the same code path. But if we use post value, things will be delayed. So this could cause performance issues. And finally, if we are using live data post value for updating UI too frequently, it can drop values, and it's not a way to go. Thank you very much. I think we might have some time for questions. Any questions at all? Have a good weekend all.